Well, welcome everybody. Thank you all for coming. We are thrilled to be here. My name is JT Rose. I'm a product marketing manager on the Azure Blockchain team. With me on stage is Ziad Rajabi. He's a principal program manager on the Azure Blockchain engineering team. And we have been out on the floor talking with many of you about the digital transformations that you have in flight and exploring how blockchain could potentially extend and expand those transformations into the processes you share with your customers and with your suppliers. There's a lot of attention on blockchain right now, a lot of dissonance. So what we want to spend the next 45 minutes talking about is just what is blockchain, what it can do, what it can't do, and most importantly, what opportunities does it present for your organizations, and how can you get started? See if this clicker works. Other way. Where am I supposed to point it? So I'll start with this quote from Marc Andreessen. I think a lot of the attention, and rightfully so, with blockchain centers around Bitcoin and its the potential to reshape the way we exchange value by potentially removing intermediaries that are sort of the traditional gatekeepers of financial transactions. This sentiment is shared by many in the press and a lot of analysts. I think what we at Microsoft sort of think about blockchain at a bit higher level, or a bit broader level. We look at the blockchain as sort of the underpinning technology of Bitcoin, Bitcoin being one application you could build on top. But we see it as the potential of blockchain as being a shared data layer that organizations can collaborate on top of and build new classes of applications, distributed applications, on top of. So let's talk a little bit about what is blockchain. When we talk about blockchain with our customers and EBCs or on the floor here today, we think about it as a shared distributed ledger, a cryptographically immutable distributed ledger. Now, Marley Gray, who's our principal architect, is going to have a 75-minute session tomorrow, and he's going to go into the sort of details and the weeds of blockchain a bit more than I will today. And I encourage you to go to that session at 9 o'clock. It'll be a really good session. But for now, let's just focus on the two sort of defining characteristics of blockchain that make it different from sort of a traditional database. The first is that it is a distributed or shared ledger. And not to complicate things, it really is a ledger, much like a database or an Excel spreadsheet. But instead of you just having a copy of it, everyone on the network has the same copy of this ledger, and they can add transactions to it. Instead of having one central actor that decides what goes in the ledger and what stays out, everyone on the network has to agree that it is true before it can go into the ledger. And that gets to the second defining characteristic of blockchain, that it's cryptographically immutable. So in order for something to be committed to the ledger, a transaction to be committed to the ledger, everyone on the network must agree that it is true. So the network has to devise a mechanism to come to consensus that something is true before it can be committed to the ledger. Now, in the public networks, Bitcoin and Ethereum, they use a sort of a cryptographic game called proof of work that you may have heard of. It's super computationally intensive, and it requires miners to sort of find a matching hash to a hash that a transaction would be represented by. In permissioned ledgers for enterprise consortiums, you don't necessarily need something as computationally intensive as proof of work. You can use different forms of consensus, different ways, different mechanisms to agree on something, the validity of a transaction, before it's committed. But I think regardless of whether you're using a public ledger or a permissioned ledger, the sort of defining characteristic is everyone in the network has to come to consensus that it's true before it can go on this ledger. And that makes this database sort of not only shared amongst potentially different organizations, but also a single version of the truth, which allows you to do some interesting things with it. So why does this matter for business? So business is built on trust, and trust is extremely expensive to build and expensive to lose. And so when you're collaborating with others, other people, other organizations outside of your own, you're placing your trust in them, that they're going to protect your customer data or handle your products in your supply chain the way you expect them to, and the way that they are contractually obligated to. That trust is not necessarily misplaced, but it does open you up to risk when you're working with other parties. And traditionally, we've used intermediaries to sort of broker that trust, or we've put in place a lot of manual validation or verification checks to sort of audit that everything's above board. What blockchain, the promise of blockchain, the potential of blockchain is to sort of remove that friction, remove the need for intermediaries to be sort of being the arbiter of trust or the broker of trust, remove the need for those intermediary steps that tend to slow down shared processes. And that's what's got us pretty excited about this. Let me give you an example real quick. A lot of folks have been coming up and talking to us on the floor about retail and industrial supply chains. So obviously, blockchain started with financial services use cases, but very quickly, folks realized the potential of this technology and its applications for supply chain. So let's imagine a grocery store, the local grocery store in Seattle is Trader Joe's, and they have a number of different SKUs, a ton of produce, and these vast supply chains that stretch all over the globe. So as an individual piece of produce comes from the farmer to the wholesaler, to the distributor, to the end retailer, each custodian in that value chain is maintaining a record of that item while it's in their custody. So the farmer may have records of how they farmed it, how they harvested it. The wholesaler may say, what condition was it in when I took custody of it? The distributor may say, at what temperature did I keep it while it was in my custody? But what happens when there's an issue? If there's a contamination issue, or if there's a need for a recall of some sort, the grocer needs to go back into that vast supply chain and into the individual databases of each participant of the supply chain to ascertain what exposure do I have in my retail stores, how can I remedy that, but also who's accountable, and how can I go fix the process at that level. This reconciliation can be incredibly timely, time-intensive, it can be costly, it's prone to errors because you're working against different versions of the truth, and it can be open to fraud. People can sort of edit their version of the truth. They can edit their database and to try to go back and revise history. So what blockchain, I think the promise of blockchain is that it can be, again, this shared backbone of truth, this shared data layer that everyone on that supply chain would be committing their transactions to, committing their version of the truth to, and we would all have to agree that it's true before it goes on the blockchain. So why isn't everyone using blockchain right now? So blockchain was not built for enterprise. It actually was built with a very narrow sort of use case in mind. At the ledger level, these things were initially built to churn out cryptocurrency. And so the initial creators didn't have in mind the idea that it could be used as an enterprise or commercial grade database. And so there are challenges when you try to use it like a database in terms of how many transactions it can process, how confidentiality works and sort of permissioning works, who can see different transactions on the blockchain and who can't. So we're working to remedy a lot of these sort of shortcomings with something called the COCO framework. We have a great white paper that's online that I encourage you all to read. I won't talk about it in depth here, but it's something that we're working on. The second sort of hurdle, I think, with bringing blockchain to enterprise is this concept of smart contracts. There's tremendous promise with smart contracts and what it can do, but they were not really designed to work with enterprise skill sets or code bases. You can't write a smart contract in C#. For Ethereum, you have to write it in Solidity. If you write a smart contract for one blockchain, you can't pick it up and go take it and use it on another. You can't take one that was written for Ethereum and go port it over to Hyperledger, for example. And a lot of these smart contracts, because they live on the blockchain, they don't trust things that are off the blockchain. So if you need to call an interest rate to trigger the smart contract, you're not allowed to go do that. There's no such thing as sort of a secure API call that you can go do. So Ziad's going to talk a little bit about later, sort of a set of middleware tools that we're building that allow you to do that more flexibly. And Marley will talk about that in detail in his session tomorrow as well. The third sort of enterprise hurdle, I think, and this is something that the folks in this room will be familiar with, is sort of scaffolding together an application around a blockchain. And so in the POCs, the proofs of concepts, the customer work that we've done, a lot of this work, it's not a trivial task to build an application around blockchain. So what we have been working on is a tool called the Azure Blockchain App Builder. Z has been sort of the chief architect of that, and he's going to be demoing how it can quickly deploy all of the relevant middleware and cloud services you would need to build an application with a blockchain at its core, so that you can focus on working on your workflows and working on your smart contracts as opposed to the plumbing of an actual application. So how do you actually get started? This is a journey that we go on with many of our customers. There's sort of 4 stages or 4 questions that we typically ask. The first is, does blockchain even really apply to my scenario? And it doesn't apply to all scenarios. And like I said, it's sort of a finicky technology to work with because it is so nascent. So it's really important to understand, is this something I need blockchain for, or can I do this with existing technologies? The second question is, if I have a scenario that's ripe for blockchain, that I should be using on blockchain, what foundation should I build on? Which ledger should I build on? The third is, how do I take this shared workflow, this cross-organizational workflow, and how do I translate it into a smart contract? And then the last is, how do you build an application around that contract? How do you build a distributed application? And most importantly, connect that to the cloud services and IT that you already have in your business, so it's not sitting on an island. So I'll talk about the first 2 of these questions, and then I'll hand it over to Z to get into the details. But I think the first one that we always talk with our customers about is how do you ascertain whether blockchain is appropriate for your scenario or not? What we find is there's really 2 different types of projects that customers come to us with. I'd say 3/4 of customers are in this efficiency bucket. Blockchain is sort of a back office tool when you think about it, and what most customers are looking to do is to reduce costs in a shared process or mitigate risk in some way. There are a handful of instances where they build something that is not just relevant for them, but is also relevant for potentially competitors or other companies, and so they look to productize it, and they think that there's interesting ways that they can build a transformational product. But most projects start in this efficiency bucket. And understanding which posture you're taking as you enter your proof of concept or enter your blockchain project is important. I think the next step is asking yourself these 4 questions. And these are, when we talk to customers about their scenarios, these are sort of the starting place that we always go to. The first is this a business process that crosses trust boundaries? And by that I mean, are there multiple organizations or departments inside your own organization that don't necessarily trust one another? They don't mistrust one another, but you're crossing an organizational or a trust boundary with this business process. Are multiple parties sharing or updating or keeping records of the same data? Are there any intermediaries in the process that are acting as sort of a broker of trust? A clearinghouse is a great example, I think, in financial services. And if not, do you have low-value manual steps in place that tend to cause friction in a process and slow things down, but are really there to make sure that everything is sort of above board? What we found is that the scenarios that answer yes to those questions, they fall across industries. We have a lot of companies in financial services and in retail and industrial supply chain that come talk to us, but also healthcare and government and energy. This is not something that's just specific to financial services. I think when we look horizontally across industries, though, there are 3 sort of patterns that emerge across all of these use cases. One is that they involve the transfer of an asset in some form, be it a physical asset across a supply chain, a monetary asset like a contract or a derivative, or a digital representation of a physical asset. They all include sort of a cross-organizational workflow. They very rarely are just specific to one company. And third, there's an element of audit or reconciliation that is usually causing pain that can be relieved by blockchain. So if you have a scenario and you sort of want to take the next step and get started, the next question is to figure out what technology to build on. And as we got started in our own digital transformation, and as we started to build internal tools that were built on blockchain, we learned a couple of things. One was that there is no one-size-fits-all ledger. We work with a lot of them. Our customers come to us with new ones each week and each month that are specific to the use case that they're building. Ethereum and Hyperledger Fabric are great general-purpose ledgers. R3, Corda, and Chain are great for the financial services sector. But customers sort of across industries come to us with an opinion of what ledger they want to use. And our posture towards this is that there is no one-size-fits-all ledger, and we want to be an open cloud for whichever ledger our customers want to use and make it really easy to deploy them in Azure. The second thing is, depending on where you are in your journey, you may want to deploy the blockchain in different topologies. From a single node sort of dev test, just want to play with it, to building a single member, single node internal proof of concept. And customers now are asking us for, how can I deploy blockchain in a multi-member, multi-node topology so I can start to build a consortium with some of the competitors or folks in my supply chain? And so we support all three of these topologies with the blockchains that are available in our Azure Marketplace. And we're adding sort of more complex topologies at the moment with some of the ledgers that are only currently supported in dev test. Whoops. So where I'll leave off before I hand it to Z is a lot of folks have come and asked me about the Cocoa framework, which is something that we released about a month ago with Mark Russinovich talked about it in New York. When we were building a stack of a platform of sort of services and products that can help developers and companies build with blockchain, Mark sort of came back and poked at the assumption that the underlying chains were really built and robust enough for enterprise workloads. And when we went back and looked at it, there were three sort of main challenges with these with the ledgers. One was that, like I said, they're built for these sort of trustless environments where multiple actors, they don't know one another, they don't trust one another, they may even have nefarious motives. And so you need a level of security that allows these actors to transact with one another. That slows things down. And so if you think about in the context of a consortium, where it's maybe members of my supply chain or competitors that I don't necessarily 100% trust, but at least I know who they are, if we're just participating in a consortium, I can relax some of the controls or some of the intensity of the consensus mechanism that's required. And that can speed up throughput. So what we found with Cocoa Framework is a Cocoa-enabled Ethereum was able to deliver 1,600 transactions a second, which is more in line with a traditional database, as opposed to somewhere around 100 transactions a second, which is something you can get with sort of off-the-shelf Ethereum. So we're making some progress there. Confidentiality is another question that a lot of our customers had is, I don't want people in my supply chain to be able to see all of each other's transactions in the chain. So how can I do role-based access? And how can I manage adding new members to the consortium? So governance was another thing that customers were asking us for, looking down the road. If you guys want to talk about Cocoa Framework, please come out to the booth. We're on the expo floor. I'm happy to chat with you about it. But what I really want to do is hand this over to Z, who's going to talk a little bit more about the next couple of steps, which is taking the workflows that you have and translating them into smart contracts.
Great. Thanks, JT. Can everyone hear me? Great. So my name is Ziad Rejabi. I'm a program manager on the Azure blockchain team. I've been on that blockchain team since the beginning of the blockchain team, which has been pretty exciting. So I got to sort of work there from the start to try to figure out what we need to go build, which has been really, really exciting. So the first step, after you've figured out sort of what ledger you want to go build, the next thing is how do you model your particular scenario or your workflow into something that can actually be driven through the blockchain. And the way the blockchain works is in the beginning when blockchain first came out, with the advent of Bitcoin, it was truly just about asset, some kind of value transfer. So I'm transferring some value, in that case Bitcoin, from one person to another. There was no real logic associated with it. With Ethereum, it came out the concept of smart contracts. So smart contracts, the easiest way to think of that is you're really driving some kind of business logic as part of your transactions. So you can start doing things like, well, I'm not going to give JT money until the weather is nice for 5 days, for example, and it needs to be sunny and over 70 degrees for 5 days in a row. Otherwise, he's going to give me money. So I can start driving these interesting business logic cases as part of my workflow and drive that as part of my blockchain. So the easiest way to think about a smart contract is think of it as a state machine workflow. And when you think of these workflows, they start at certain states. You have certain types of personas that can actually interact with each of the states and take certain actions at those states, and it goes on to different types of states. Once you define those workflows and that sort of state machine, that represents the business logic that's sort of codified through what is called a smart contract. These smart contracts contain that logic, and they contain sort of the state that is defined at each particular part when you have different characters that can actually interact with those different states. And I'll show you guys sort of how that kind of works in a real demo in a little bit later here. But when you look at smart contracts all up, there's a couple of limitations that I think if you've played around with them, you'll hit almost immediately. First, every sort of blockchain stack out there has their own concept of a smart contract. And what that means is they have their own proprietary language in some cases for defining what a smart contract is. So in the case of Ethereum, for example, they have Solidity. In the case of Hyperledger Fabric, they have a subset version of Go. In whatever case you're talking about, there's limitations with respect to what can actually be defined as part of those smart contracts. So for example, in Solidity, it's very difficult to do something as simple as string manipulation, which, if you're looking at any other language out there, is really easy to go do. The other limitation with smart contracts is by design, the way smart contracts work, is everybody participating in the blockchain. Let's say all of us are a part of a blockchain. If I'm trying to run some proprietary algorithm or some proprietary workflow, every one of you guys have access to that business logic. I cannot hide my proprietary IP in there. And so there's that limitation as well. Another limitation is by design, they limit the amount of computation that can be powered for those particular smart contracts. And the reason for that is because if every one of us have access to that smart contract, the way to drive towards consensus is that every one of us have to basically execute that smart contract to drive towards that same value. So we can all agree on the exact results. Now, the limitation in computation, the limitation in terms of the language, and the limitation with respect to actually being able to gather information. So for example, if I'm trying to gather information that's existing outside of my blockchain, let's say, for example, I wanted to calculate interest rates. I want to go get the latest interest rates at 4 p.m. every single day and calculate loans that are going to be driven through my transactions in my blockchain. I can't do that in today's world with blockchain because I'm basically breaking the security properties of the blockchain itself. So these kind of limitations are what we've seen customers hit with smart contracts. We've seen it ourselves. And we've taken a look at that and said, what can we do to actually address that kind of concept? And so Marley tomorrow is going to go and talk a lot more in details with something called enterprise smart contracts and cryptlets. But I'll give you guys a really high level of what that means. What we're designing is a way for people to execute business logic outside of the smart contract, outside of the blockchain, sorry, and have that execution exist in a secured environment, and have the results then get pushed back into the blockchain in a way that still maintains the integrity and security level of the blockchain itself. And what that really means is, instead of having your business logic be pushed into the data tier, which it is today, so it's like me saying, if you're going to run a database, put all your business logic into stored procedures, which I'm sure you guys would come look at me like I'm crazy to go do that. But that's kind of how smart contracts work today. Instead of doing that, write your business logic in whatever language you want, execute it in whatever way you want to execute it, and maintain that integrity of the sort of the blockchain through this concept of cryptlets that sort of drives the results back into the blockchain. It's basically you're pulling that business logic away from the data tier and putting it into its own tier, which is kind of what you're used to in today's world when you're developing sort of your applications, from a presentation layer to a business layer to a data layer. And the nice thing about that concept is by allowing you to write in whatever language you want, you're not limited by the language and the subset capabilities of the smart contract. And also by running it into your own sort of enclave or sort of secured environment, you're able to execute the code in whatever kind of computational power you need. So if you need to scale it up, let's say you're doing some kind of data modeling or something like that, you're able to execute that and leverage your computational power that you need. And so essentially you're dealing a lot with sort of, you're increasing your productivity when you're developing your applications because now you can use whatever language you want. And you're able to interestingly increase the security level of what you can actually accomplish with respect to your blockchain applications and actually increase the types of scenarios you can accomplish. Because now you can go grab data from outside. Your execution could run a lot more computationally expensive algorithms and workflows that you just couldn't do possibly before. And the other thing that's really nice is now you're not limited to a language per blockchain. You can write your language one time, let's say in C# or Java, whatever it may be, and then have that business logic execute on any type of blockchain. So it makes your code a lot more modular and scalable with respect to whatever kind of blockchain stack you're working against. Again, Marley will go into a lot more details, and actually he'll show you a demo of Cryptlets and enterprise smart contracts working, so I really encourage you guys to check out his session tomorrow. So the next thing is, okay, well, now you have sort of, if you think about sort of this blockchain, you've developed a workflow on top of it, but how do you actually build an application on top of it? And so one thing we've seen, something I like to call sort of this blockchain island. The way blockchain makes you feel like today is it's like me throwing you into this deserted island all by yourself. It's like the blockchain island, and it's not connected to anything. And when you're trying to develop an application on top of blockchain, what you're going to really need to do is you need to connect it to other things that you care about, like your identity system, being able to extract information from your blockchain and run machine learning, analytics, visualizations on the data. You're going to need to monitor the information of what's going on. It's very, very difficult. It's basically taking a technology and you're needing to sort of connect it to everything else that you care about. And that's really hard to do. So what we did is this visualization here gives you a good visualization of sort of what our strategy is with respect to blockchain and how we envision sort of making it easier for customers like yourselves to build blockchain applications that are true enterprise grade. So the first thing is when you look at the bottom layer of the stack here, what we're calling Ledger Core, the first thing we did is let's make it as easy as possible for you guys to deploy whatever network you care about as easily as possible on top of Azure. And so if you go to Azure Marketplace today, you can easily go and deploy Ethereum, Hyperledger Fabric, Chain. There's a whole bunch of different stacks out there that we support across different topologies. That was step one. That's purely IaaS, where you basically control your infrastructure yourself. The next level on top of that is something we're building, is trying to make that more managed. So now you don't have to deal with upgrading all the VMs, upgrading sort of the blockchain network itself. Let us take care of it and let us manage it. So that's much more of like a PaaS infrastructure at that point. Then the next thing we're doing at that level is we're developing this Coco framework. This Coco framework, as JT mentioned, is really going to help accelerate what you can do and what you can develop on top of blockchain because it addresses some of the big limitations of blockchain stacks out there, such as its throughput and speed. But that's all good. That gives you sort of the infrastructure. But the next piece is sort of connecting that to everything else that you care about. And that's when you move up the stack, you get to the middleware. Middleware basically takes that island and starts building bridges from that island to everything else you care about. So when you look at blockchain today, blockchain has its own concept of identity. It has public and private keys. And so when you're looking at building an application on top of blockchain, the first thing you'll notice is a lot of applications today will require you to sort of authenticate using those public and private keys. Now, the problem is when you're sort of building an application that's enterprise grade, you're not going to want your customers or your users to know about the identity system that you guys use currently today, whether it's Azure Active Directory, Google, or Facebook. And you don't want them to also know about the blockchain identity. So what we're doing is we're building up a set of middleware services that basically abstracts away the complexity of the identity system of blockchain, because it's kind of different from each of the stacks, and abstracting that away, and then leveraging Azure Active Directory or any kind of third party or even other types of identity management systems, and using that as your primary identity system for the blockchain itself. The second piece is extracting information out of blockchain is very, very difficult today. So running analytics, running machine learning on it, visualizing that data is really difficult. And so we're creating a set of services that really makes that a lot easier. The secure off-chain execution is that whole concept of cryptlets and enterprise smart contracts that we're building that really tries to change the way that people think about business logic all up for smart contracts and for blockchain. And then lastly, I would say as you move up the stack, we start thinking about sort of integrations with first and third-party applications. So how do we integrate blockchain with Office 365, SAP, Dynamics, Salesforce kinds of applications? And so that gives an opportunity for building up these vertical and horizontal solutions that are geared towards certain industries. And one of the things that we have, and JT announced this as well, is we have something called the Azure Blockchain App Builder that I'm going to show you guys a demo that we're kind of announcing. That's going to be part of the private preview program. And essentially what this application does is it will automatically build a full end-to-end application for your blockchain by just inputting it, by giving it as input smart contracts or business logic. You give it business logic, and you get a full end-to-end application that is fully integrated with a bunch of these middleware services. I'm going to show you guys a demo of how that actually works. This is really at a high level in terms of the architecture that we've seen. So JT mentioned this. A lot of times when people are developing blockchain solutions, there's a bunch of scaffolding work that people have to go do. Scaffolding work there is connecting it to a lot of the middleware services that I just mentioned before. When we think about this, we've designed this sort of, and App Builder sort of leverages this kind of architecture in mind. It leverages this concept of leveraging some kind of ingestion hub, like an event hub or a service bus, that's able to sort of be sort of the entry point of information coming into the system. And the way that we have it set up is the information comes into this ingestion hub, and we have it syncing with the blockchain, so writing out transactions into the blockchain, and then syncing that data back out to an off-chain data storage location. So syncing your information to like a SQL database, for example. And then at the same time, being able to leverage integration points with other types of inputs, like IoT, for example, with blockchain. So you have your sensor information coming in and participating in sort of your workflow and your blockchain network as well. And then once everything is into sort of an off-chain storage location, you can imagine being able to easily pull that information out and start creating interesting visualizations and analytics and machine learning based on the information that's being pushed into the system. So with that in mind, I'm going to show you guys now a demo of a particular scenario. And so several of you guys have come to us and talk about sort of supply chain. And so I'm going to give you guys a demo of a supply chain scenario. In this particular case, I'm going to talk about refrigerated transport. In this particular example, imagine we're transporting milk. And so as we all know, milk should be transported at a certain temperature range and a certain humidity range. Otherwise, the milk will get rotten and will affect consumers downstream. So super simple. You produce the milk. It's going through some kind of processing place, and then it gets transported from one carrier to another carrier to another carrier until it finally reaches the retail store. And what we're doing is we wanted to leverage the concept of IoT inside here. So the IoT devices can keep track of your temperature and humidity and even potentially your GPS while you're transporting the goods to ensure that at every step along the way, that the goods that are being sort of carried and transported meet the standards and the compliance standards of transporting those goods. So pretty simple, and I'm going to show you guys how that actually all works. So the first thing is we have something, like I said before, called the App Builder. Once you deploy the App Builder will automatically build either a web-based application or a mobile-based application, an iOS or an Android app for you that has the full UI built in based on your workflow and based on your smart contract. So you give it the smart contract, and everything here is sort of generated for you. So once you try to log in, once you try to go to the site, it's going to ask you to authenticate. And so the nice thing about this is we're leveraging Azure Active Directory as the primary identity system for the application. So in this case here, I'm going to sign in with my Microsoft credentials. And you'll notice here that it's going to, oh, I already signed in before. Let me log out here real quick to show you guys sort of the authentication mechanism. So it's going to take me to my organization sign-in. As you can see here, this is the Microsoft IT sign-in experience. And I'm going to go ahead and sign in. And because I'm off network, it's going to do a two-factor auth. So the nice thing about leveraging Azure Active Directory is that it automatically gives me the two-factor authentication for my blockchain application. So I'm just using my Authenticator app to two-factor auth here. Once I have authenticated, I get signed in. The next thing you'll notice is that it's pulling my identity from Azure Active Directory. So again, I've completely abstracted away the identity from the blockchain and leveraging my primary identity system. So you can see here my avatar picture, my name is all being pulled from Azure Active Directory. And with Azure Active Directory, I can assign people certain groups or certain roles. So in this case here, I'm an administrator. And as an admin, I can do a couple of things. We have several different demo contracts that are sort of built into the application itself, where you can demo things. One of them is going to be this sort of refrigerated transport scenario. We have other kinds of scenarios as well for different kinds of industries. You can upload your own custom contracts. So once you've defined your contracts, you can upload them, and then they will automatically be built up as applications within the app builder. And the last thing you can do here is you can assign users different roles for the particular workflow. So in this case here, you can see telemetry compliance is basically the refrigerated transport scenario. And you can see here I've given different users different roles or personas based on my workflow. So for me, you can see that I'm initiating counterparty, and I'm the owner. So I'm the owner of the supply chain, and I can initiate sort of a workflow based on that scenario. So I'll just go back to my view. Once I've assigned myself different scenarios, every single scenario will show up here as a contract. And so I'll go ahead and click on this telemetry compliance. And one thing I do want to mention here, and I want to give a big shout out to Sajika, who helped us out as a partner of ours. They helped build this application, or this particular demo that I'm showing you guys, and it's leveraging Hyperledger Fabric as the backend. So we've developed this to work on Hyperledger Fabric and Ethereum. And the front end is exactly the same. Everything is exactly the same, except when you're sort of interacting with Hyperledger Fabric versus Ethereum, you just have a different type of smart contract or business logic that you can push in. So in this case here, the first thing you'll see here is we have a tabular view of all the contracts and all the workflows that have been instantiated based on this particular scenario. And again, everything here is automatically created from you visually. And so this just shows you a table here of the states of all the different contracts that have been created, who the initiating counterparty is for those particular goods. And the counterparty and the previous counterparty, it just sort of gives you an explanation of where it is in the supply chain in terms of transportation. And it gives you sort of information about sort of the temperature and humidity readings from the particular devices. So what I'm going to do is I'm going to create a new contract. And when I click create new contract, this view that I'm getting here is automatically generated again based on the workflow that I've created. So I'm going to say, for the sake of this demo, I'm going to use a simulated device for IoT. But we do have this working with real IoT devices. And if you guys want to see that, come by the booth and I can show you guys how that kind of works. But in this case here, I'm going to say simulated device is the identity or the entity that will keep track of the IoT readings. And one thing I do want to mention here, instead of sort of interacting with or representing people or things in my blockchain as sort of these addresses, instead what I can do is I can represent these people as people leveraging Azure Active Directory. So here for the supply chain owner, I can say, I'm the owner. The observer can be the government regulator. And then I can specify the minimum humidity and temperature that I want the IoT device to start reading. So here I can say maybe 15, and maybe 75 for the humidity, and then temperature would be 4 degrees to 10 degrees. So if I hit submit, I basically start creating a contract that gets pushed out to the blockchain. And now what I can do is anybody who's sort of been sort of represented in this particular contract gets notified about this contract being created. And now the IoT device is sort of triggering data that gets pushed into here when things are out of compliance. So in this case here, what I'm going to do is you can see the contract got created. And I'm going to just click on it. And this view here shows me all the actions that I can take on this contract given who I am and given the state of this particular contract. This view here gives me all the people that have interacted with my contract at this particular time. This view, this card here, gives me sort of what the state of the contract looks like at this particular time. And then it gives me a full audit trail of who did what action at what time and where on the blockchain everyone exists. Again, everything here is created for you automatically. In this case here, what I'm going to do is I'm going to transfer the goods to, let's say, for example, Contoso Shipping, because I don't want the goods to be bad on my watch, so I'm going to hit submit. And at that point, we're basically sent these goods now to Contoso Shipping. And once those things are shipped to Contoso Shipping, what I'm going to do is I'm going to sign in as the device. So I have here in my in-private browser, you can see here I'm a simulated device at the top. I'm just going to just hit refresh here, just to show you. So you can see this contract that I just created is in transit right now with Contoso Shipping. And you can see here with all the particular information that I specified in my previous action. So I'm going to just throw in some, again, this is a simulated device. I'm going to just throw in the results of my IoT device. Again, if this was a real IoT device, it would just be doing this automatically for me. So I'm going to throw in a proper humidity reading of, let's say, 35, but I'm going to make the temperature go up to 50. So it's out of compliance. I'll just put a timestamp on it and hit submit. So what I've just done here is the IoT device now just read a really bad temperature. It's submitting it. It's being thrown to the blockchain. Everybody on my supply chain now is going to get notified that the reading got spiked up to 50, and so the shipment is now bad. And we know exactly which counterpart or which party is involved at this time. So in this case, it's Contoso Shipping that's responsible for being, having a bad sort of a reading at this point. So if I go back out here, oh, it got red here, so it says, you can see the state now is out of compliance. Everyone gets notified that something is bad. So this just shows you sort of integration between IoT and blockchain and how everybody sort of gets notified in the supply chain when something is happening that's not looking good. So on that note, I'm going to hand it over back to JT.
Thanks, Z. So in summary, we have a few minutes left, and we can leave some time for questions. I want to leave you with this. Microsoft is committed to this journey. We're committed to bringing blockchain to enterprise based on a couple of principles. We want to bring it on your terms, whether it's in the cloud or on-prem through Azure Stack, and with the blockchain of your choice. It needs to be integrated with your business, which is a lot of the work that Z and the engineering team are doing, is connecting the blockchain to the IT assets and the existing infrastructure that you all are using today. And the third is with enterprise assurance. Like I said earlier in the discussion, these tools were not necessarily built for enterprise, but we can get them there. So wherever you are on your blockchain journey, I encourage you to come talk to us. We're down, like I said, on the expo floor, and we're going to walk down there after this. And if you guys have additional questions, please come grab us, come talk to us, share your scenario with us. We're excited to talk to you about it.
So if you guys have any questions, we have a few minutes here. You guys can come up to the microphone and ask some questions.
John Welch, I'm involved with the healthcare industry. How far are you along with cooperation with the federal government with regard to making sure these businesses are on the up end rather than criminal enterprises that are trying to keep their endeavors secret?
Sorry, can you repeat the question? Is how...
Are you coordinating with the federal government's approval? Like, I'm involved with the healthcare industry.
Sure.
And as long as we have reputable people and companies involved with this, but this could be a tool used for illegal purposes, possibly. And has the federal government been improving what Microsoft has been doing with blockchain in all your development?
Yeah, so the easiest way to sort of address your question, yes, we work very closely with government and regulators to sort of talk about how to have blockchain enable enterprise applications.
Good.
And so we're involving some of those guys in some of these consortium concepts. Any other questions? Otherwise, we're at the booth downstairs. You guys can ask these questions down there. Yeah, go ahead.
The concept of the cryptlets and separating business logic away from the blockchain, what does that do in terms of being able to trust publicly the code that's running inside the cryptlet itself? Is there a mechanism to provide public trust for that?
Yeah, so the best answer for you I can give you is go to Marley's session tomorrow. He'll go and talk into details of exactly how we're accomplishing that scenario. But we're leveraging basically hardware enclaves to maintain the trust level and integrity of executing the code outside of the blockchain and still maintaining the integrity of the blockchain itself.
Okay. All right. Thank you.
Yep.
Hey, Z.
Left side.
Oh, yeah, okay.
So, with FINRA requirements, there's worm storage. Is that something that the blockchain can address in the future? You know, with the write once, read many. There's a lot of verticals that deal with that now, and it seems like that could be a good use case.
Yeah, so the blockchain, yes, it does deal with this sort of write once, read many times kind of database structure, but it does more than just that. Yeah, I do understand there's a bunch of different technology out there that does something similar, but blockchain by itself, if you look at all the underlying technologies, there's nothing new there. It's just the combination of everything that is kind of new. So the way I would address that is just sort of, you have to combine it with different things, and then it starts getting to be much more similar to a blockchain.
Thank you.
Yep. Yes?
Quick question. So right now, in the transaction speed, I think it's around 30 transactions per second, for example, in public blockchains. When do you foresee, a higher throughput rate that gets us closer to traditional relational database transaction speed, for example, in the hundreds of thousands of transactions per second, for example?
Yeah, so JT mentioned that. So we actually created a Cocoa framework. Think of that as like a wrapper that wraps around the blockchain. That wrapper, what we took is we took plain vanilla Ethereum. I think it went from like 10, 15 transactions per second to 1,600. That was just from our prototype. We think we can actually squeeze quite a bit more out of that.
What kind of time frame are you envisioning?
So the time frame for the Cocoa framework, we're trying to get something out for next year.
Okay.
It's still in development phase, but at some point we're going to open it up for a private preview for customers as well. It's just not ready yet.
Okay, thank you.
No problem. Any other questions? No? Okay, we're good.